This is part 2 of our 7th grade practice test. So we've been working on chapter 2, we've been working on order of operations. We're really combining all of our skills involved in fractions, decimals, whole numbers, and integers. So rational number operations is the title of this practice test for chapter 2. We already talked about page 1 in part 1, so we're moving on to the problem solving. This is on the 2nd page of your practice test. And I'm just going to show some lines here because I'm thinking we're going to need a little bit of space to show some of these. So here we go. It says problem solving. Notice that these are multiple point problems, just like on the test. So the idea is really to show your work and get to a good answer. And remember, if I give you words, give words back. So in this case, we have word problems. We want to answer in word form somehow. It says solve, show your work. Number 8. The highest outdoor temperature ever recorded in the United States was 134 degrees Fahrenheit, measured at Death Valley, California. The coldest outdoor temperature recorded was a negative 79 8/10 degree Fahrenheit, measured at Prospect Creek, Alaska. Find the difference between these two temperatures. Oh, I notice a magic word here. It really says I want to find a difference between the two temperatures. Well, difference to us, hopefully, will remind you that we want to do a subtraction. So I don't think this one is so bad to be able to show on our actual practice test here. I want to take that 134 degrees Fahrenheit and I want to take away this 79 8/10 degrees Fahrenheit. Notice that I put this negative 79 8/10 in parentheses, really just to remind myself I'm taking away a negative. Well, if this were the situation, hopefully you'd remember that we can change a minus to a plus, change the sign of next. That also means that I can add the opposite. So now I have a rule that I can apply, which we often refer to as same signs, add and keep. So off to the side, I really would want to stack these up and make sure that I pay attention to my decimal alignment. But where is the decimal in 134? I don't see it. Oh, that's right. It would be at the back of the whole number. And I might need to put some placeholders back here in a minute. Let's see what happens. 79 and, oh, I said and. I need that decimal aligned, and I need them lined up because I'm adding or subtracting my decimals right now. And I'll put the 8/10 at the back. Well, if you go back, we've turned these into an addition step. I'm really combining positives and positives at this point. I might want a placeholder at the back, and I can go ahead and add. What's 0 and 8? 8, of course. 4 and 9, 13, regroup the 1. 7 and 3 is 10, plus 1 more makes 11. We'll regroup the 1, and 1 and 1 makes 2. This number doesn't seem to make sense to me. I only had 134, and I'm only adding about 80 to it. Should I ever jump to 2,000 something? No. Remember this decimal alignment. We need to bring the decimal down when I'm adding or subtracting. So we'll fix this, and this now becomes 213 and 8/10. Well, that's not bad to write here. It's a small piece of pizza if you're trying your pizza math and organization today. But the problem is, this isn't a final answer. They gave me words, I need to give words back, so it says find the difference between these two temperatures. 213.8 what? Oh, we're measuring in degrees Fahrenheit, degrees Fahrenheit. Sounds like degrees Fahrenheit would be a shortcut, okay? A real quick label. That's a little bit better. What else could I say? The difference between Death Valley, we'll make it their ownership, they own that temperature. Death Valley's highest temperature and the other place we're comparing was Prospect Creek. Prospect Creek. But remember, that wasn't their high, it was their coldest temperature is 213.8 or an 8/10 degrees Fahrenheit. This is a much stronger final answer. It shows that I understand the context of the problem also. Let's fast forward to number 9 here. We have a group of tourists. They're viewing the U.S. national parks. Their tour bus starts its journey at an elevation of 138 feet below sea level. Oh, that sounds important. I'm going to highlight it right now. The bus stops for a short break after ascending. Oh, that sounds important. Ascending 470 feet in elevation. What is the new elevation of the bus relative to sea level? I can picture a vertical number line for this, so off to the side I'm going to sketch myself a quick vertical number line. It says that they start their tour below sea level. That's pretty important. 0 would be sea level here, so I'm just going to sketch that out real quickly. And below sea level would mean underneath or less than 0. So I'm going to move down here and I'm going to put a point that says 138. But that doesn't make much sense, does it? 138 isn't below 0. So because it says below sea level, I can go back here and indicate, oh, it's talking about a negative. I'm at a negative 138 feet. Notice it says that I'm going to ascend. On this trip, you take a short break, you're ascending 470 feet in elevation. What does ascending mean? Well, if something's ascending, it's moving up. So ascending, I'm adding on, ascending, and adding start with an A. So over here, I really want to show that I'm going to move upwards 470 feet. That doesn't mean above sea level 470 feet. It just means from where I started, I want to move up 470 feet. Well, I want to figure out my location here. Where am I going to land? So to do that, I really could approach this a couple different ways. I could maybe figure out the difference between these. I could say I had 470 feet and I took 138 feet away from it. Whatever's left would really represent this piece. I could maybe even think of this in absolute value. I could talk about the distance. That would also be another way to approach it. So I think I'm going to start with this idea of I have a negative 138 feet and I'm thinking about using my integer rules here, and I'm just going to ascend or move up a positive 470 feet. Well, to do that, I would have to apply the rule different sign subtract. So off to the side, I would take my 470 and take away my 138 and see what happens. Looks like we get an answer of 332. 332 what? Let's dig back in and find that question. What is the new elevation of the bus? Oh, a new elevation. So when I talk about elevation, we're talking about measuring in some type of unit. Was it feet, meters, kilometers? Oh, feet it is. And would we say that this is above or below sea level? Because notice it says relative to sea level. Well, I think it would make the most sense to say we ended up higher than 0 or above 0 on our number line. So we want to say 332 feet above sea level. You could absolutely turn this into more of a sentence format, and if you do, you don't want to start with a number and numeral form. You want to write it out, but that's the right idea for now. Number 10. Jessie needs 1 5/8 gallons of paint to paint her room. She only has 5/6 gallons of paint. How many more gallons of paint does she need? How many more is a big clue to me. This is oftentimes talking about a comparison, or in this case, subtraction. So what does she have to start with? This 1 5/8. How much am I taking away? The 5/6 she already has. So how would I go ahead and simplify this expression? Well, if you remember, we need some common denominators to make that work. So in this case, what would work for 8ths and 6ths? Maybe 24ths? I could turn both of these into 24ths and see what we get. Well, this whole number can stay the same, and 8 times 3 got me 24, so 5 times 3 gets me 15. And how about here? 6 times 4 got me the 24ths, so 5 times 4 gets me 20. Oh, this would be great, except take a look at your numerators. 15 take away 20 is a little bit tricky to show. So at this point, I think I would probably turn this into an improper fraction. We would probably turn this into a format of m over n. Well, 24 times 1, or 1 whole, is the same as 24 24ths, plus 15 more. Well, that seems like it will get me 39 24ths. And I want to take away 20 24ths from that. Well, my denominators match, so I can really just subtract my numerators and keep my denominator and see what we get. So it looks like 39 take away 20 is 19, and these are still 24ths. 19 24ths looks like a decent answer, but it's kind of embarrassing. It's missing something called a label. So how many more gallons of paint does she need? 19 24ths gallons more are needed. Or we could go back and talk about Jessie and say she needs 19 24ths of a gallon more. Okay, let's keep going here. part 3 is page 3 of our practice test. And again, I know that you can fast forward in YouTube and grab whichever pieces you need. So we'll just keep going here if we can. It says, number 11, Mrs. Williamson wants to buy 2 t-shirts and 6 pairs of socks for her children. Each pair of socks costs $3.60 and each t-shirt costs $15.80. If she only budgeted $50, how much is her budget short? Interesting, we might need to grab a couple pieces here. How many t-shirts does she want? 2. How many pairs of socks? 6. Each pair of socks costs $3.60. Oh, that goes with the socks. So I'm going to write that right here. $3.60 each. And the t-shirts. Well, I need this $15.80. That's just for one t-shirt, isn't it? So up here I could record next to my t-shirts $15.80 each. Well, next I need to really figure out her total bill, don't I? And then it says that she's going to be short, and she's trying to budget $50. So if $50 is the budget, this is really what she's starting with. So I could start with $50 too. And I could show you that I'm going to take away 2 t-shirts. Well, 2 t-shirts, and they each cost $15.80. Isn't that the same as 2 groups of $15.80? Or 2 times $15.80? $15.80. It is. I also want to take away 6 pairs of socks. Well, that's 6 groups of something. It's 6 groups of $3.60. Notice I did remove my labels just to work out the decimal multiplications here and some subtraction that I'll have to do in a minute. And that's okay to do as long as we go back and figure out the context when we go to answer finally. So what happens here? We really think of Pemdas or Gemdas, depending on which one you prefer. Well, parentheses first, but there's nothing to do in parentheses, so exponents next. There are no exponents. Multiply or divide in order from left to right. I do have that. I have a multiplication here and also here, which we can deal with right now. So 2 groups of 15 would be 30, and 2 groups of 80 cents would be $1.60 more. Looks like I'm going to get $31.60. How about this? 6 times $3 is $18, and 6 times 60 cents is $3.60. So 18 plus 3, 19, 20, 21, and 60 cents more. I think we've got it. I want to bring down everything else that we haven't dealt with yet. And if you don't believe that this math works out, you're definitely welcome to off to the side. Oops, helps if you write the right numbers though. And we'll try it this way. Do some checking. 2 times 0, 2 times 8, 2 times 5 plus 1 more. Oh, yep, decimal bank. It worked. I got $31.60. You can check the same thing with the shirts if you like. I'd probably put the $3.60 on top. Whether or not you keep that 0 on there is really up to you. It just affects your decimal jumps in a minute. Notice I'm using the decimal bank. I'm thinking to myself, in decimal multiplication, how many times did they divide by 10? Well, once, twice. And for 6, no times. 2 total jumps. Yep, this checks out. The next thing that I have left is subtractions. And if you remember, addition, subtraction get to go in order from left to right. So here we go. First subtraction that I need to deal with is sitting right here. And some students I know like to change a minus to a plus, change the sign of next, or add the opposite if you will, and change it to different signs subtract. We still need to subtract here. So, trying not to ruin my pizza, we'll move off to the side and try some subtraction. 10 take away 6 is 4, 9 take away 1 is 8, 4 take away 3 is 1. And don't forget, decimal addition, subtraction, bring the decimal down. Looks like I have $18.40. It's positive because the farther number is positive, so this is going well so far. And I want to take away $21.60. Oh, this is why they say she'll be short. Notice you're taking away more than you have. So oftentimes we would add the opposite. Change a minus to a plus, change the sign of next. And we'd have to apply the rule different sign subtract. So off to the side here, not to ruin your pizza. Take that first number, or the farther number I should say, and let's subtract $18.40 from it. We want to figure out what the difference is here. Looks like I end up with $3.20. So if I was working out my pizza here and I still had room, $3.20. Now be careful. I did different sign subtract, but there's a rule that says keep the sign of the farther number. So which number's farther? Oh, there's more negatives than positives. It looks like she is $3.20 short. I'm pausing our video for a minute. I'll be back. Judy Schumann?